voltage will be stepped down from the higher value to the lower value. Okay. Now, winding details. First step here, design steps of LV winding. Design step of LV winding. Calculate the number of turns per phase using the equation. LV winding in the bracket it will be a secondary winding, because normally a distribution transformer with stepping down from higher voltage to lower voltage. So secondary voltage will be a low voltage winding. Likewise, the primary voltage will be a high voltage winding. Okay. Step 1. Calculate the number of turns per phase using the equation. Using the equation. Say here you have two formulas. Either one you can use. Okay. Since it is LV winding and also it is nothing but a secondary winding. So calculate number of turns per phase using the equation TS. TS means what? Number of turns of secondary or number of turns of LV winding, or low voltage winding. Number of turns of secondary winding. If you use this formula, TS is equal to what? Vs by ET. ET is something about voltage per turn, and V is something about the secondary voltage or a low voltage or a low voltage side. Otherwise, if you use this one, TLV is equal to what? Low voltage voltage of secondary winding. That's low voltage winding. Low voltage of secondary winding, VLV, okay, divided by ET. Either one you can use. Otherwise, you can use TS is equal to Vs by ET, or TLV is equal to what? VLV by ET. Okay. So number of turns per phase, TLV is equal to what? VLV by ET. VLV nothing but the voltage on the secondary, low voltage. Nothing but the voltage means lower voltage on the secondary for single phase transformer. Similarly, for three phase transformer, we are going to take what? We are going to take the per phase value. Okay, voltage on secondary per phase, we are going to take it. This is for what? To calculate number of turns per phase. Likewise, you can calculate what to find the secondary phase current IS. Secondary phase current IS or ILV. Secondary current or low voltage current. ILV is equal to what? KVA into 10 power 3 by Vs. Secondary voltage, or KVA into 10 power 3 by VLV. Secondary voltage is nothing but your low voltage. Either formula you can use it. ILV is equal to KVA into 10 power 3 divided by VLV. VLV is nothing but the voltage on the secondary side for single phase. And here for three phase, here you multiply by 3. Only difference is what? Here for three phase, multiply the low voltage, the voltage into 3, secondary voltage into 3. Likewise, obtain the cross-sectional area of LV conductor, because that depends. If you are going to say stepping down the voltage, means the cross-sectional area of the low voltage will be different with respect to the high voltage. Where the high voltage, the voltage will be more. So definitely the cross-sectional area also differ. So obtain the cross-sectional area in mm square of LV conductor, means a secondary winding conductor. Secondary winding conductor. So AS represent what? AS represent for secondary conductor. Or cross-section of LV, low voltage winding, both are same. AS or ALV is equal to what? IS by delta S or ILV by delta LV. ILV is nothing but current on the low voltage winding. What you are going to already going to find out here. What? Here ILV you are going to find out here. Same thing you are going to use here. ILV by delta LV. The delta is the current density in ampere per mm square. So normally the current density remains same for both primary and secondary voltage. That is regarding what? To calculate the to calculate some particulars of LV winding or secondary winding. Okay. Normally, what you are going to calculate number of turns. You are going to calculate what is the secondary current or low voltage current, and you are going to find out the cross-sectional area of the secondary winding or low voltage winding. Likewise, we are going to find out the design steps of HV winding, nothing but the primary winding. HV winding, nothing but the primary winding. Calculate the number of turns using the equation, same thing. TP means turns of primary is nothing but on the HV side, THV is equal to VP by ET, or THV is equal to what? VHV by ET. This is nothing but a high voltage, high voltage and the primary winding. Okay, voltage and high voltage, nothing but your primary winding divided by ET for single phase. For three phase, for phase you have to calculate. Okay, THV is equal to VHV for phase divided by ET. This is for three phase. To find once again the secondary phase current, that is nothing but your primary current. IP or IHV is equal to KV into 10 power 3 or VHV, or you can use this formula. If you use IP means use this formula. If you use IHV means use this formula. KV into 10 power 3 divided by VHV. Okay. For single phase, likewise for three phase, you multiply into 3. That is for three phase. And the same thing, you calculate what? You calculate the cross-sectional area of the high voltage side, high voltage winding. AP is equal to what? IP by delta S or high HP by delta HP, where delta is the current density and current density remains same for both primary and secondary. Okay. With this, I will continue with the problem. As I told earlier, I have 5 problems. We will go on entire analysis of the 5 problems. Determine the main dimensions. Determine the main dimensions of the core, the number of turns, and the cross section of the conductor. So here, main dimension, along with the main dimension and even core. What extra you have to do here? Number of turns and cross section of the conductor, means number of turns of primary, number of turns of the secondary, and you have to find out the cross section of the conductor of primary and secondary. Okay. For 5 kVA, 1100 bar 400 volts. So you can see here, this is nothing but a distribution transformer. You're stepping down the voltage. This will be a primary voltage or high voltage, and this will be a secondary voltage or a low voltage. 50 hertz, single phase 4 type distribution transformer. The net conductor area in the window. The net conductor area in the window is 0.6 times the cross section of the iron in the core. And this is the formula. This is a condition given. The net conductor area in the window is 0.6 times the cross section of iron in the core. So earlier in the theory, I explained that what should be the copper in the window. Okay, what should be the copper area in the window? What should be the copper or amount of copper in the window, actually in the window area? Those things we have a formula there to calculate. Okay. Assume a square section of the core. Suppose a square section. A flux density is 1 Weber per meter square. Current density is given. Window space factor is given. The height of window is 3 times the width. So height of the window HW is equal to what? 3 times the width. These are the conditions given. By using these conditions, you have to find out what? You have to find out the main dimension of the core, and you have to find out number of turns of primary and secondary, and cross sectional area of the conductor of primary and secondary. Okay, now, with coming to this statement, the net conductor area in the window is 0.6 times the cross section of the iron in the core. We have formula. What is the window space factor? The window space factor is nothing but what? Conductor area in the window. And the conductor area is nothing but what? How much copper you are going to wound on the window. Wound on the window. Okay. If you have figure. Okay, go back to the figure. Just explain you regarding that one, and I'll come back. Okay, I'll take this one. This figure I'll take you. Okay, see here. This is called as a window area. In that, how much you're going to wound the primary winding and secondary winding. Whether you entire height of the window you're going to wound, or only the 3/4 you're going to wound, or only half you're going to wound. Once again, it depends upon the voltage rating. Okay, that this represents what? Window area, and this represents your conductor area. So conductor area divided by window area will give what? Window space factor Kw. Okay, window space factor Kw. Okay, that's the thing. Let's continue with the problem. So the net conductor area in the window is 0.6 times the cross section of the iron of the core. With respect to this statement, you can write what? The window space factor. The window space factor Kw is equal to what? Conductor area in the window, something about your AC, divided by total area in the window, something about your AW. Okay. So I want what? The net conductor area. What is given here? The net conductor area in the window. The net conductor area in the window AC is equal to what? Kw into AW. AW is something about what? Area of the window. AW into AW. What is given the net conductor area? It is 0.6 times the cross section of the iron in the core. Means it is 0.6 times the net iron in the core. Net iron in the core is something about what? Net iron area is something about AI. 0.6 times the cross section of the iron in the core. So 0.6 times the AI, net iron in the core. This is the condition. So AC is equal to Kw into AW. That is equal to what? 0.6 into AI. So, and from this you can calculate what? You can calculate the window area here. So what is the AW? Window area. So AW is equal to what? 0.6 AI divided by KW. So KW is something about what? Window space factor. In the problem, it is given that window space factor is equal to 0.2. So 0.6 AI divided by 0.2. What you get? 3 AI. So what is window area now? AW is equal to 3 into AI. So after finding out area of the window is equal to 3 into AI. Once again, area of the window is something about what? Height of the window into width of the window is equal to 3 into AI. So, to find out this area of the window, I have to calculate what? I have to calculate this AI, net iron area I have to calculate. How can I calculate net iron area? So, I can use the output equation of a single phase 4-type transformer and I can calculate what? AI. What is the equation? Q is equal to 2.22 FBM AI kWW delta into 10 power minus 3 kVA. So, in that you can calculate here as here. So in that equation, what is Q here? Q is something about what? Okay, this step is not required. Q is equal to 5. So it is 5 kVA. Okay, 5 kVA. Now what is this one? See here, kW into AW. So what I have to calculate? I have to calculate what? I have to calculate AI. So from this equation, just neglect this step. This step is not required. So from this equation, I want to calculate for AI. Okay, I can calculate for AI. So AI is equal to Q divided by entire this term. And AI is equal to Q divided by entire this term. Okay, now. So you substitute for what? KW into AW. So what is KW into AW? 0.6. Okay. KW into AW is something about what? 0.6 AI. Okay. So it's a pretty here. KW into AW is equal to what do you got here? 3AI. Sorry, KW is got here. AW is 3AI. Okay, substitute here. Now, okay, either way I can do it, no problem. So AW is what here? What you got here? 3 into AI. Okay, now 3 into AI. So AW you can substitute here. What is AW here? AW is equal to 3 into AI square, and then 3 into AI. And what you got here? And here and here what you got? Here you got one more AI. So one more AI will be there here in this. So that you take it to this side. So what you will get? 3 AI square. This is one way of doing. Or other way of doing also explain another problem. Either way you can do it. Once again I'll explain here. After finding out AW is equal to 3 to AI for single phase 4-type transformer, use this relation. From this relation, okay, write it for AW. So what you get? 5 divided by entire this term. And what is AW here? 3 into AI, and you got one more AI here. That you take it to this side. So what will you get? 3 AI square. One more method is there. I'll tell you in the next problem. So 3 IA square is equal to entire this term, and AI square is equal to entire this term. And calculate AI square, substitute all the things, substitute what is given in the problem for all AW, KW, everything you substitute, and calculate AI square. AI square is equal to AI square, and calculate AI. What is AI now? AI is equal to 0.00732 meter square. That is your equation 1. So once you find out AI, this one, I can find out what? I can find out the area of the window. Where of the window is nothing but what? Height of the window into depth of the window. Okay. Now, first I have to find out what? First I have to find out the dimension of the core. I have to find out dimension of the core. And we know that the relation here, AI is nothing but what? KS into AGA. So first you calculate what? A gross core area. Gross core area AGA is nothing but what? AI by KS. AI is nothing but what? KS into AGA. So net iron core area is nothing but what? KS into AGA. Where AGA is nothing but a gross core area, which includes the net iron area plus insulation. Okay. AI is nothing but a net iron area without only the pure iron part. K stacking factor represent the what is the percentage of insulation. So AGA is equal to what? AI divided by KS. Substitute for AI 0.073 divided by 0.9. You can see here 0.0814 meters square. If you see here, net iron area is equal to what? 0.0732. What is gross core area? Definitely it will be greater than your net iron core area because you are going to include the insulation. Insulation is around 10%. So if you divide by 0.9 means another 1% is there now, that is representing insulation. So what is AGA now? AGA is equal to what? 0.0814. If you compare this value and this value, you can see that the gross core area is more compared to the net iron area. Because why? Because of the insulation part. They are going to spray the varnish for both the side of the core. So once you calculate AGA, since it is a square core means what? Your depth, your width and depth will be same. So AGI is equal to what? A and A square. A is equal to square root of AGI. Put the AGI value. Then what you get here? The cross section of the core A is equal to what? 0.09. Means width and depth both will be same. Okay, per square. So A is equal to 0.09. This will be the first answer to find out what? To find out the dimension of the core. So A is equal to 0.09. But then try to find out the what? Try to find out the window area. Now window area AW is about 3 into AI. 3 into AI. A is already calculated here. Substitute here. What you get? 0.0219 meters square. And area of the window is equal to what? Height of the window into width of the window. And one more condition is given that is the problem. The height of the window is 3 times its width. So height of the window is equal to 3 times the width. Use these conditions and use this equation, and you can find out what? You can find out the HW and WW. So height of the window is what? 3 times the width. So 3 into WW into WW, what you get here? 3 WW square is equal to 0.0219. From this you can calculate width of the window. Likewise, you can calculate the height of the window. Okay, height of the window is equal to what? 3 times the width of the window. Likewise, you can calculate the height of the window and the width of the window. So once again, you have to find the main dimensions, overall length of the frame and overall height of the frame, overall length and overall height. So let us calculate the dimension of the yoke. Now depth, since it is square, depth of the yoke dy square means the depth of the yoke will be what? Will be same thing. Depth of the yoke, you can see here. Since it is square, it's rectangular here. Think it's as a square. So both depth and height will be same, A and A. Height of the yoke will be A, and depth of the yoke also will be A. This is rectangular, but think assume it as a square. Both will be A and A. Okay. So depth of the yoke dy is equal to A, 0.09. A already calculated here. And height of the yoke, HY is equal to A, 0.09. Area of the yoke, depth of the yoke into height of the yoke, put it there, what you get? 0.081 meter square. The next, since it is a single phase port type, you can calculate what? You can calculate what? Overall height of the frame. Next, you calculate what? Overall height of the frame, H is equal to what? HW plus 2HY. HW plus 2HY. HW you know, HY you know, substitute and you find out. It will be in meter. Overall height of the frame. Overall height of the frame is entire thing. HW plus 2HY. Overall length of the frame, W is equal to D plus A. So D, I don't know D, you calculate. Distance between the adjacent length, D is equal to what? WW plus A. Okay, that I think already I explained in the last class. D is equal to WW plus A. Further, if you require something, I will tell you. D is equal to WW plus A. If you have, okay, here you can come here. This is D. D is nothing but what? Capital D. Adjacent distance between the the distance between the two adjacent limbs, the center of two adjacent limbs. So D is equal to what here? This is WW plus half D plus half D. So D plus small d. Okay. This is already told in last class. Okay. So that is what D is WW plus. Okay. D is equal to WW plus A. Okay. Otherwise, you can calculate. I want WW plus. I think. Okay. I'll go back to here. I want capital D. Okay. Taken here. I want this T. So if I want to calculate this capital T means, okay, I want overall width here. See, okay, not you can't take T because I want overall width here. See, width is nothing but what this one. So I want the width. So what I can calculate here, W is I can calculate what for this overall width means I can calculate here WW plus. Okay, WW plus half D plus half D I can calculate. Otherwise, I can calculate what? WW plus, here what you are required. Say D represent this one. You can see you have a gap here. After circumscribing circle, you have a gap here. Don't take this T. But this width of the frame represent what? Represent only this. It has not included this gap here. Okay. After the diameter of circumscribing circle, this gap you don't include. So width of the frame does not include this gap. So what I have to take, I have to consider what I have to consider this A. So I want to calculate D. If I want to calculate D means what I have to do, I have to take I have to take WW plus half A plus half A I have to take. Because this width of the frame up to here only. So width of the frame is up to here only. It's not considering this part. Okay. But the diameter of circumframe circle include this part also. But the width of the frame does not include this part and here this part. So don't take that part. So for that, what I have to do, I want WW plus half A plus half A. Okay, so T is equal to what now? WW plus half A, here, you can see here, plus half A plus half A. Then what you get? T plus A. That you be sure. Okay. That is regarding what? Where is it one? Yeah. So WW plus A. Okay. So overall width is W is equal to what? D plus. Okay, D plus A. Since D I don't know, so you calculate what? WW plus A. Otherwise, you can calculate, no problem. D, if you want to calculate, you can calculate what? WW plus D. Once again, you have to calculate what? Your diameter of circumference also you have to calculate. That also you can calculate, but not required. A simplest method you can do it. Okay. So once you calculate this one, you substitute there and find out what width of the or overall length of the frame, overall length or width of your window, width of your nothing but width of the frame or overall length of the frame. Okay, find out W is equal to D plus A. What we got here 0.265. Okay, this is regarding what overall dimensions, area of the core, and even the dimensions of the load. But after finding out these things, what are the main things? You have to find out what you have to find out the winding details. To find out the winding details, I require ET. To calculate ET, voltage per turn ET is equal to 4.44 F5M. F5M can be written as what? BM into AI. So 4.44 into 50 into 1 into 0.0732. Okay. Then what you get? 1.625. Once you know ET, I can calculate what? I can calculate the low voltage winding. Turns in low voltage, TLV is equal to what? VLV by ET. Otherwise, you can use this formula. TS is equal to what? VS by ET. Either one you can use. TLV is what? VL by ET. VLV nothing but the low voltage voltage on the secondary winding. Okay, low voltage winding. 400 divided by 1.625, 246 turns LV winding. Okay. Then what is the current? Current on LV winding or low voltage winding. ILV is equal to kV into 10 power 3 divided by VLV. What is the kVA given? 5. 5 into 10 power 3 divided by 400. What do you get? 12.5 amperes. And calculate the area of cross section of LV winding or secondary winding, LV winding. ILV by delta LV, nothing but current density. Current density is given 1.4 ampere per mm square. Keep it in mm square only. Keep it here in mm square only. So 12.5 divided by 1.4 ampere per mm square. So ampere get cancelled. So what you get? 8.93 mm square. This is regarding winding details of LV winding. Likewise, you can find out what winding details of HV winding. So THV is nothing but what? VHV by ET. You put voltage on HV winding, nothing but your primary winding. Okay, otherwise you can use TP divided by VP by ET. That formula also you can use it. So 11,000 divided by 1.625, 6769 tons. Similarly, find out IHV, kV into 10 power 3 by VHV. So I find out 0.45 ampere. Similarly, find out the area of cross section of HV winding, IHV by delta HV. Put the values. So what we got here? 0.384 mm square. Okay. This will be a lengthy problem. This type of problem will last for 12 marks, more than 10 marks. They will last. If they ask the entire dimensions and windings, they'll go for 12 marks. 12 marks or 14 marks they'll go. Okay. With this, we'll go for second problem. So for each problem, I'll take a different conditions and try to solve the problem. Now, determine the main dimensions and the winding details of 100 kVA. Once again, the main dimensions means everything you have to calculate. Main dimensions and winding details. Main dimension means entire thing, dimension of the core. You have a capital H and capital W, HWWW. Possibly calculate even the dimension of the core also. Once you want to find the main dimension means definitely you have to find out the dimension of the core also. Winding details of 100 kVA, 2000 bar 400 volt, 50 hertz, single phase, shell type oil immersed self-cooled transformer. This is shell type. Assume voltage per turn 10 volt, frequency 1.1, current density 2 ampere, window space factor 0.33. the ratio of window height to window width. Here, this is the condition given. The ratio of window height to window width means HW by WW equal to 2.5, and the ratio of core depth. The ratio of core depth means core depth is 2A and width of the central limb. Core depth is B and width of central limb is 2.5. Means it is a shell type transformer. Okay, it is a shell type transformer. Shell type. So in the shell type, you know that if you see the figure of a shell type, okay, just I'll show you. This is shell type. You can see here, where you have what? You have a winding on the central limb. What's the area of the core? Area of the core just is the area, and it's nothing but what? The width will be 2A. You can see here, the width will be 2A, and depth will be B. 2A into B. It will be what? The area of the core. 2A into B. So depth will be B, and width will be 2A. Okay, and that is regarding what the area of the core, area of the core for shell type. Okay, so that is given the problem here. Okay, that is given the problem. The ratio of core depth. The ratio of core depth is nothing but your B, and the width of central limb. The width of central limb is nothing but your 2A equal to what? Equal to 2.5. The stacking factor is 0.9. Okay, these are two conditions. HW by WW is equal to 2.5, and B by 2A. B by 2A is equal to 2.5, and stacking factor is 0.9. So based on these conditions and data given, find out the main dimensions and winding details. Now, voltage per turn, it is equal to, find out voltage per turn here, it is equal to 4.4 for a 5 MVA, 4.4 for VM into AI. Okay, then find out. So if they give voltage per turn, it is easier to find out what is, it is easier to find out AI. Once again, based on the data given, try to calculate the AI, net error area. If they give ET means, it's easy to find out what AI. Okay, so AI is equal to ET divided by 4.4. Otherwise, if you don't give ET, if they don't give ET means, then these are the steps you have to follow it. So you go through the problem twice, thrice, based on the data given, and try to solve the problem. Okay. So ET, when they give ET, you can calculate AI. AI is something about what? 0.041 meter square. Once you know AI, I can calculate what? I can calculate AGA. Gross core area AGA is something about what? AI by KS. 0.041 divided by KS is something about what? Stacking factor 0.9. And this is something about what? Gross core area 0.0445 meters square. You can see here, if you compare these two values, gross core area is more than the net iron area, because the gross core area includes the insulation part also. 0.0445 square. And gross core area AGI. Gross core area AGI for shell type, the width will be 2A and depth will be B. 2A into B. That is your gross core area for, once again I show the figure, gross core area for shell type. Okay, this is nothing but 2A. I think I missed here. I'll put once again the correct figure. This is 2A and this is B. Okay, 2A into B. Okay, 2A into B, and from the condition, you can see the condition here. The ratio of core depth to width of central limb. Core depth is B, and width of central limb is 2A. B by 2A is equal to what? 2.5. These are the conditions given. B by 2A is equal to 2.5. Also, HW by WW is equal to 2.5. So now B is equal to 2.5 into 2A. The gross core area AGI 2A. Except for B, what is B? B is something about 2.5 into 2A, 2.5 into 2A, 2A square into 2.5, 2A square is AG by 2.5. AG is already you know what is the AGI? 0.0445. Substitute here, calculate 2A. And what is 2A here? 2A is equal to 0.135. And if you want to calculate A also, okay, A also, because the width is 2A and depth is B. If you want to calculate A, you also calculate A, no problem. So 2A is equal to 0.135. Once you know 2A, you can calculate what? You can calculate the depth. So B is equal to 2.5 into 0.135 is equal to what? 0.335, 3375. So that is your depth. So what is the dimension of the core? Dimension of the core is nothing but what? 2A into B. So 2A is equal to 1.375, and depth B is equal to depth B is equal to 0.3375. That is what dimensions of the core. Since it is a shell type, width will be 2A and depth will be B capital small b. Okay. After finding out the core dimensions, let us calculate what the window dimensions and overall H and W. Once again, for shell type, what is given, this is the equation. And from this equation, what you calculate here, you calculate AW. Okay, calculate AW. So substitute here, KVA is 100, substitute 2.22 frequency, 1.1, 1.1 is something but the frequency. AI already calculated AI, what is AI? 0.041. And what is Windows space factor? 0.33. What is delta? 2 into 10 power 6 into 10 power 3. So you calculate AW. Also AW is equal to what? HW into WW is equal to what? 0.0303 meter square. Okay. So from this you find out what, from this try to get HW. So HW is equal to what? 0.0303 divided by WW. So you know that, you know from the relation HW by WW, condition HW by WW is equal to what? 2.5. So substitute for HW here. One step I missed here. HW by WW is equal to 2.5 from the condition. So from the condition, the window height to window width, it is 2.5. Use that relation. Okay. HW by WW is equal to 2.5. What is HW from this equation? This is HW. Substitute here. So what I can get, I can find out what? I can find out WW and I can find out HW. Once you find out the width of the window and height of the window, I can calculate what? Depth of the yoke. So depth of the yoke for shell type, dy will be B because depth of the yoke will be B. If I go back to the figure, this figure, depth of the yoke, this will be what? This will be depth of the yoke, B. Okay, dy is equal to B. Okay, dy is equal to B, 0.3375. Height of the yoke, hy, height of the yoke will be A itself. Height of the yoke, if you go back to here, height of the yoke here, height of the yoke will be A. So for shell type, depth will be B, height of the yoke will be A. If I go to shell type transformer, if I go back to that figure shell type, if you remember shell type transformer, okay, once again I'll go to you. Already explained, but still I'll once again show the figure. Okay, this is your shell type. What is the height of the yoke here? Height of the yoke is nothing but A. A is nothing but what? The width of the side limbs. This is the width of the center limb. This is the width of the side limb. Okay. So HY is nothing but what? Height of the yoke is nothing but a small A. Is nothing but the width of the side limbs. And depth. This is your depth. Depth of the yoke will be what? Here, depth of the yoke will be P. Means this depth here. We take 3-dimensional view. The depth will be what? Depth will be B. Okay. That's the thing. So depth of the yoke, height of the yoke will be A. So once you know dy and hy, you can calculate what? You can calculate the AY. Dy into hy, calculate AY. Then you can find out overall height of the frame. Overall height of the frame, HW is HW plus 2A. Overall height of the frame there. If you see that figure, HW plus 2A, overall height of the frame. And overall length of the frame will be what? 2W plus 4A. If you go back to that figure, okay, if you go back to the figure, overall height, HW plus A plus A, HW plus 2A, overall W, overall your length or overall width, what do you get here? WW plus WW, 2WW plus 2A plus A plus A. What you get? 2WW plus 4A. That is nothing but your overall length of the frame. So overall length of the frame, it will be 2WW. 2WW plus 4A, 2 into 0.12 plus 4 into 0.0675, 0.51 meter. This is overall dimensions. Then what you have to calculate? You have to calculate the winding details. You can use same formulas here, LB, TB, same formulas you can use, 400 by 10, you can find out the number of turns. Likewise, current in LB winding, you can find out. And area of cross section, you can find out. Okay. Delta LV is given as 2. Okay. Likewise, you can find out what? Find out for HV winding. For high voltage, you have to put it here, 2000, it is 10, and you can find it. You can find out what? LV winding details and HV winding details. Okay, this is for what? The second problem. So I'll go for, I have another 15 minutes. So okay, let us see. I'll go for another 1 or 2 problems. Okay, this is a very much interesting problem, and the 7th problem, very much interesting one. And this problem has asked several times. and here a little bit tougher one, and because they give more data, and this problem has been asked several times. Let us go to the problem. Determine the main dimension of the core and the number of turns, say same thing, dimension of the core, number of turns, and area of cross section of conductor of primary and secondary. Means you have to calculate area of cross section. Area means AS of primary and secondary. Of 125 kVA, 6000 power, 460 volt, 50 Hz, single phase core type distribution transformer. Maximum frequency, okay, these are all the current density is given. Assume cruciform core, means you have to assume two separate core. For an assembled core, allowing 8% insulation for 8% insulation for the insulation between the lamination. Here, what they consider the 8% insulation. So, if you think, if you use this formula here, if you use this formula, what AI is equal to KS into AGA, net iron area is nothing but what KS into AGA. So normally, you'll consider for 10% insulation. So we did the table for what, for square, for two-step, for three-step, and four-step. From the table there. From that, I can get the two ratios and I can get AI. That table, the values in that table will design for what? Design for 10% insulation, where case is equal to what? Case is equal to 0.9. 0.9 means the 10 considered into a 10% insulation. So what once again I show the table there in the theory part. Okay, see here this table. What I given in this table, all this value will consider this. All this value here you can see it. This is considered for 10% insulation. Okay, 10% insulation means for the lamination they'll go for at least a 10% insulation. Okay, but in the problem it has been stated that instead of 10% insulation, you're going to take only 8% insulation. They're giving the details that don't go for 10% insulation, you go for 8% insulation. See, for a cruciform assembled core, allowing 8% insulation between the lamination. Don't go for 10%, you go for 8%. Literally. Then, taking yoke cross section has 15% greater than the core of the window. So the yoke cross section, you take the 15% greater than window. Means if you take it as 1, you go for 50% more. 50% more, I can go for 1.15. 50% more than the core of the window. Okay. Window height is 3 times the window width. Net cross section of the copper. Net cross section of the copper means conductor area is 0.22 times the net cross section of the iron core. Means conductor area in the window is 0.22 times the net cross section of the iron core. Window space factor is 0.3. Draw a neat sketch to the suitable scale to show the values. Here you have to draw the neat sketch. That overall height, overall height, overall width, height of the window. Those diagram, those figure you have to draw and you have to show the details. Okay, this is the important problem and a little bit lengthy here. We'll go one by one. Okay. First condition. See here how to go to the problem. The net cross section of the copper means the copper area in the window. So what 0.22 times the net cross section area of the core. So what I can use this formula. The window space factor KW is nothing but what conductor area in the window divided by total area of the window. AC by AW. So net conductor area in the window AC is equal to KW into AW is equal to what? 0.225 into AI. Okay. So what is given is 0.22 times the net cross section, net cross section of the iron in the core. So 0.22 times 0.225 into AI. Okay, there is nothing but your conductor area. So what I have to calculate? This is your nothing but your AC conductor area 0.225 AI. Now let us calculate what? Try to calculate this. AI. So you can use what? You can use this. You can use what? You can use the output equation of a single phase. Q is equal to 2.22 FBM AI KW AW delta into 10 power minus 3 kV. Okay. Now you can use here. This is the equation. I'm substituting this values here. So for this this you got what? This you got AI. Okay. And KW AW. Yeah, KW, because window space KW is given in the problem, window space factor. Okay, so here in this problem, you see that they are not given window space factor. KW also is not given. Okay, KW is not given, endless space vector is not given. So entire this part you take it. Okay. This one. Okay, AC is nothing but what? KW into AW. So KW into AW here, since in the problem KW is not given, so you take entire this part. KW into AW is equal to what? 0.225 AI. So substitute for here. You already got here AI. KW into AW substitute here. 0.225 into AI. So 0.225 into AI. Into 250. What is here? What is given here? 250 current density 250 ampere per cm square, centimeter square. Check here. It is not mm square. It is centimeter square. So 250 into 10 power 4 into 10 power minus 3 kVA. So after substituting here, I can calculate what? I can calculate this AI. So 0.2225 AI square equal to 125 divided by the entire remaining part. 2.250 to 1.22, 0.225 AI square. Okay, 0.225 cancelled here. Okay, this is cancelled here. Okay, I'll make the correction here. It is not there because I have taken already here. Okay, 1.2, just make a change here. Okay, 1.2 into 250 into 10 power 3 into 10 power minus 3. Okay. So AI square, can you put it here once again? This thing, okay, leave it. Already it is there here only. Once again, I bring back to here. Since I have taken here, I can take only the AI square here. Okay. Do one thing. This part I'll remove it. Let it be 0.225 here. I remove this part. I change this part. AI square. So AI square, what we got here? 0.04 meter square. And substitute here and calculate AI. AI is equal to here. In this step, just I'll remove this one. I'll only take AI square. I remove this part. Okay. So AI is equal to 0.04 meter square. Once you find out the AI, then first our step is what? To calculate the dimension of the core. So for cruciform core with the 10% insulation, KS is equal to 0.9 and AI is equal to 0.56 D square. Where I've taken from that table. Okay, for 10%, if you consider for 10% insulation, KS is equal to 0.9 and AI is equal to 0.56 D square. Because we have done this analysis for cruciform core. But in the problem, they are told that. You, instead of 10%, you take what? You take instead of 10%, you take what? You take 8%. So with 8% insulation, definitely this stacking factor will change. Okay, this you remember. With 8% insulation, Ks is equal to 0.92. That you have to do analysis, but you remember this one enough. This is for 10% insulation, but in the problem it has given that you take 8% insulation. For 8%, Ks is equal to 0.92 and AGA means gross core area is equal to 0.62 D square. So if you take 10%, you did the analysis. In that AGI got 0.6 D square. If you go back to that analysis, you check it out. You have AGI is equal to 0.6 D square. But for 8% insulation, we take Ks is equal to 0.92 and AGI is equal to 0.62 D square. This is very much important. Remember this step. So net iron core area AI is equal to what? Ks into AGI. So 0.92 into 0.62 D square. What we got here? 0.57 D square. So for 8% insulation, what I got AI? 0.57 D square. For 10% insulation, what is AI? 0.56 D square. Nothing. The only difference is what? 0.01 difference is there. If you go for 8% or 10%. So the main thing what this calculation that is very much important one. So in this width-wise, depth-wise calculation, there will be minor difference, but this calculation you have to show it. So net iron area for AI is equal to Ks into AGI. For 8% insulation, what I got now? 0.57 D square. So calculate AI is equal to 0.57 D square. Calculate D here. D is nothing but what? Diameter of circumscribing circle. What you got? 0.264. So for this one, we have for cruciform core, A is equal to what? 0.85 D. Width of largest stamping. In that analysis I have done, A is equal to 0.85 D. So A is equal to 0.85 into D. What is D here? 0.264. So once you calculate, what you get the cross section area of the core. Cross section area of the core of cruciform A is equal to what? 0.224. The width of largest stamping, even the width and the depth will be what? Both will be A for cruciform. If you go for cruciform core, if you see a cruciform core, both width and height will be same. Okay, depth and height will be same. Okay, the depth of the yoke will be equal to the depth of the core. That will be equal to what? Width of the largest stamping. Both will be equal to A. A is equal to what? 0.224. So once you find out the core dimensions, then you can find out what? You can find out the other things. So you can consider a single phase core type transformer. Take this equation. Okay. Now once you know AI, then you can calculate what? Area of the window. Substitute the values here. Find out area of the window. Area of the window is nothing but what? HW into WW. And it has given that the condition height of the window is something but what? 3 times the width of the window. And height of the window is 3 times the width of the window. What is the height of the window here? And this into width. So okay, now what is height here? 3 times WW, and you can find out what? Width of the window and the height of the window. Yoke cross section. Here one more condition is given. What is the one more condition given here? The yoke cross section is 15% greater than the core of the window. Means yoke cross section, that yoke part is 50% more than the core part. That you take it into consideration. The yoke cross section has 15% greater than the core section. Okay. So area of the yoke, nothing but what? dy into hy, depth of the yoke into height of the yoke is equal to what? 1.15 of area 1.15 means 15% more than the core section. So what I can take 1.15 AI. Okay, 15% more than your core section. 1.15 AI. Okay. And then area of the yoke is equal to substitute for AI. AI already calculated 0.04. What you get area of the yoke? 0.046. So hy into dy is equal to 0.046. So area got it. So depth, then the depth of the yoke. Depth of the yoke is nothing but what? Dy is equal to A. Dy is equal to A, 0.024. And once you know depth of the yoke, you can calculate what? You can calculate the height of the yoke. So depth of the yoke you know. Height of the yoke you calculate. This is the part. Then you can calculate what? The distance between the, then overall height of the frame you calculate. H is equal to HW plus 2HY. Put the values. Overall length of the frame, W is equal to D plus A, and D how do you calculate? WW plus A. That you can use it. Okay, that you can use it. WW plus A. Or you have, okay, that one you use, no problem. WW plus A. This formula you use it, and you calculate D. You put in the T value here, then what you got? 0.548 meter. This is what, nothing but overall length of the frame. Likewise, you calculate for winding details. First you calculate ET, then you calculate the winding details of LV winding and HV winding details you calculate. Okay. These are three, you got 2 more problems. Okay. I will take the 2 more problems in next class. Then I'll go after solving 2 more problems in next class. I will start the theory part of what no load current. Okay, some theory part I'll start tomorrow class, and we'll continue with the next part, what we call as to find out the no load current of a transformer. Okay, 11:30. Calculate the net cross section of the core. So once again, you have to calculate the net cross section of the core, whether it is a square or a rectangular or a 2-stepped or 3-stepped core. Gross area of the core is nothing but AGI. Core dimensions. Core dimensions is nothing but same thing. If it is square means A and A. If it is rectangular means A and B. If it is a 2-stepped means once again A and A. Likewise, 3-stepped and 4-stepped you can calculate. And window area HW and WW, and dimensions of window, nothing but the length of the window or length of the window. Dimensions means same thing. Or length of the window means your capital H and capital W. Or length of the frame and overall height of the window. Those things you have to calculate. Okay. Overall height of the frame and overall length of the frame. And you can calculate even the yoke area also. Okay. So for 200 kVA, 6600 watt 250 volt single phase shell type oil immersed self-cooled distribution transformer based on the following parameters. So window space factor is given, maximum flux density in the core 1.20, average current density delta is given. Window proportion here, you can see a window proportion 2.5:1 means HW by WW. The ratio of HW by WW is nothing but what? is given as what? 2.5. The ratio is 2.5. Okay. Means the height is more compared to the width. The rectangular core, the rectangular core proportion. Since we have taken the shell type, in shell type you can see that the width will be 2a and depth will be b. The rectangular core proportion is what? 1.8:1. Definitely, the depth will be more compared to your rectangular core. If this is a if this is a shell type, if this is shell type transformer, the depth b will be more compared to the width. Width is 2a and depth is b. So depth will be more compared to your width of the central limb. So if we take a 1.8:1 means this 1.8 corresponds to the depth because depth will be more compared to the width, and this one is corresponds to the width. Okay. Once again, the net cross section area of copper in the window is 0.2 times the net cross section of the iron in the core. That is the condition given. Assume tacking factor is equal to 0.9. This is a very much important problem with respect to a shell type transformer. So the condition is given that net cross section of the copper in the window is 0.2 times the net cross section of the iron in the window. You can use the same formula here. The window space factor Kw, conductor area in the window divided by total area in the window. So net conductor area in the window AC is equal to Kw into Aw is 0.2 times 0.2 times the net cross section of the iron in the core. So 0.2 into Ai. Okay. So AC is equal to Kw into Aw, 0.2 into Ai. Q is equal to you take a single phase cell type. This I'll change it here. This is shell type transformer. Okay. Q is equal to 2.22 FPM into A kW. This is nothing but the output equation. I try to substitute here. So output the kV output is nothing but 200, 2.22. Frequency is 50. BM is 1.1. And you substitute for kW to AW. What you got here? kW. I think what they given. Window proportion is given. Window space factor is not given. So what you can do? Okay, what you can do? Directly substitute for kW to AW. Okay, so substitute for kW to AW is nothing but what? 0.2i. Okay, so then 2.2 is nothing but current density 10 power 6 into 10 power minus 3. 2.2 ampere per mm square current density. Substitute these values and calculate AI net iron in the core, nothing but AI. So 0.2 AI square. So AI square is equal to substitute everything. At this point, it come to the denominator, and AI square is equal to 0.00232, and AI is 0.048. This is nothing but the net iron area in the core. But what they have asked the problem, they asked what? Gross area of the core and net cross section of the core. Okay. So net cross section of the iron area in the core is nothing but AI. Then next you have what you have to calculate the gross iron area. What is the gross iron area? AGI. AGI is nothing but what? AI divided by KS. 0.048 divided by KS is given as 0.9 stacking factor. Okay, 0.0533 meters square. This is what gross core area. And one more thing, since if you go back to this shell type transformer, and this is what? This is the core area. Width is 2a and depth is what? Depth is b. So what you have to calculate? You have to calculate this b and this a because b is greater compared to your 2a. So what you have to calculate? You have to calculate this b and you have to calculate this 2a. Okay, you have to calculate. So what you got AGI? AGI is something about 0.0533 meters square. Now rectangular core proportion. You know that rectangular core proportion of shell type transformer is something about 2a into b. So 2a is the width, this is 2a is the width, and b is the depth. So 2a into b. So always they'll give proportion in terms of what 1:8. And you should come to know that the depth is more compared to the width. The width of the central limb. Depth is more compared to the width. So what I have to write here? So 2a into b is to 1:1.8. So 1 is corresponds to 2a and b because the depth will be more. B is corresponds to 1.8. Like that you have to write it. So 2a into b is equal to what? 1:1.8. Depth is 1.8 and 2a is equal to 1. Come back here. 2a into b is to what? 1 into 1.8. So if you see this equation, the depth is what? The depth of the core. The depth of the core is 1.8 times the width of the central limb. With 1.8 times the width. So I can write here what? 2a into b, so 1 into 1.8. I want to write b. So depth of the core is 1.8 times the width of the central limb. So 1.8 into 2a. If I take width of center limit 2a, because it is what? It is 1. So 2a is equal to 1. Then b is equal to what? 1.8 times the width. So 1.8 times the width. So b is equal to what? 1.8 into 2a. 1.8 times the width. So now come back here. AGI. AGI is equal to what now? 2a into b. Nothing but your gross core area. Gross core area of the core is nothing but what? 2a into b. This is gross core area. 2a into b. Gross core area means what? Along with the iron part, we have some insulation because we divided by 0.9. This 10%. What you got 10% is nothing but for insulation. If you compare these two, this is meter square. Compare these two, you can see here. Net iron area is nothing but what? 0.048. And you can gross iron core area, nothing but what? 0.533. Definitely it is more because in gross core area, along with the iron part, we have an insulation for each stamping. Okay. Now, AGI is equal to what? 2a into b. 2a into b is equal to 0.048. Substitute for b here. What is b here? B is what? 1.8 into 2a. So 1.8 into 2a, 0.048. So 2a square, the substitute here, 2a square is equal to 0.0236. And 2a you get what? 0.163. And if you want to find out a also, a is equal to 0.0816. And b, calculate b is equal to 1.8 into 2a. 2a, what is 2a here? 2a is 0.163. Then what you get b? 0.294. So, what is the first part of your question here? Net cross section of the area of the core. Net cross section area of the core means you have to calculate the 2a and into b. And gross core area is nothing but AGI and core dimension. Core dimension is nothing but what? Once again, 2a into b. Okay, these things you have to calculate. Okay, and those are the 3 points here: net core section, net cross section of the core, gross area of the core, core dimensions. Okay, these things you have to calculate. Nothing but you have to calculate 2a and b. You have to calculate. After finding out this 2a and b, and then what your dimensions of the core, 2a and b, then try to find out the dimensions of the window. So for single phase shell type transformer, this is the output equation. So substitute here 200, 2.22, and you got what? You got the AI is equal to 0.048, and substitute for delta. This is nothing but area of the window. Area of the window is equal to 0.0554 meter square. Even area of the window is equal to HW into WW. Think about height of the window into width of the window. This is the thing. From the condition, it is given from the condition. Height, the ratio of height of the window to the width of the window is given as what? It is given as 2.5. Window proportions is nothing but what? 2.5. Height of the window to width of the window is 2.5. Use that condition. Okay. Use this condition. HWW is what? 2.5. So HWW is equal to this equation, and then what is that one? HW is 2.5 WW, so 2.5 W whole square. From this, you can find out what? Width of the window and the height of the window. After finding out width and height of the window, always you can calculate the depth of the yoke. So depth of the yoke will be dy is equal to b. The depth of the yoke, this is a yoke part. The depth of the yoke will be what? This is something about your b. Okay, and dy is equal to b. So you substitute the value of b here. Already we got the value here 0.294. Substitute here, and height of the yoke hy is equal to a. You know that height of the yoke hy. Nothing but hy is equal to this a. Make the width of the side limbs. Hy is equal to a. Hy is equal to 8 at 0.0816. So finally, you can calculate the area of the yoke dy into hy for 0.0239 meters square. Once you find out the dimension of the yoke, you can find out the overall height of the frame. H is equal to HW plus 2a. Same thing. Overall height HW plus 2hy. 2hy is nothing but what? A. 2a. Okay, hy is equal to a. And then you put the values and calculate the overall height of the frame. And overall length of the frame, overall length of the width of the frame, W is equal to what? 2WW plus 4a. So 2WW, you know that this is 2WW, 2a plus 2a, 4a. Okay. Just put the values here, and what you get here is 0.63 meter. This is nothing but what? I have found out the overall dimensions of the window, and you have found out the dimensions of the core. Along with that, what you have to find out? You have to find out the winding details. So voltage per turn, it is equal to 4.44 F into 5M. So phi m can written as what? Bm into AI. Bm is given as 1.1 and AI calculated 0.048. So what you get voltage per turn? 11.72. Once you got voltage per turn, as usual, you can calculate what? Winding details. For a low voltage winding, number of turns, low voltage, and LVO, low voltage nothing but your secondary winding. Okay, 250 divided by 11.51 turns. Likewise, you calculate the low voltage current, 800 amperes, and calculate the cross section of the low voltage winding, nothing but your secondary winding, ILV by delta ILV, what you get? 364 mm square. This one cross section, keep it in mm square itself. Okay, if they give mm square, keep it in mm square. If they give centimeter square, keep it in centimeter square. Likewise, you can calculate for what? HV winding. THV is equal to VH by ET. You calculate number of turns of HV winding, what is the current in the HV winding, and the cross-sectional area of the HV winding. Okay, use this formula and you can calculate. Okay, this is what a solution for the particular this problem, very much important one. They may ask. Okay, I'll go for a final problem with respect to the winding details. Ninth problem. Okay, calculate the dimensions of the core, the number of turns, and cross-section area of the conductor. The same thing, dimension of the core, number of turns, and cross-section area means calculate everything. Dimension of the core, dimension of the window, main dimensions, everything you should calculate. And the cross-section area of the conductor. Cross-section area of the conductor with respect to LV winding and with respect to HV winding for single-phase shell type oil immersed transformer, assuming, and this is a condition, assuming ratio of magnetic to the electrical loading. The ratio of magnetic to the electrical loading is 480 into 10 power minus 8. The ratio of magnetic to electrical loading is 480 into 10 power minus 8. The maximum flux density in the core is 1.1 T. Current density is given, interest vector is given. And here, ratio of depth of stacked core. The ratio of depth of stacked core to the width of center limb. The ratio of depth to the width of central limb is 2.6. What the ratio of depth means? What depth is nothing but B, width is nothing but 2A. So B by 2A is equal to what? 2.6. And HW is 2.5, K is equal to 0.10. So in this problem, we have two conditions here. This is the condition. Assuming ratio of magnitude to electrical loading, this one you have to take it into consideration. And the ratio of depth to width of the central limb means nothing but B by 2A is equal to 2.6. These are the two new things it has been given. So come here, regarding this one, the ratio of magnitude to electrical loading, if you remember when we derived for voltage per turn, it is equal to K under the root of Q. This is what KVA, K under the root of Q, where K is equal to what? K is nothing but the constant, is equal to 4.44 FR into 10 power 3. This R, if you remember while doing the derivation, R is nothing but what? Phi m by T. This phi m by T, phi m by 80, 80 is nothing ampere turns, phi m is nothing but the maximum flux. So the ratio of magnetic to electrical loading. So phi m corresponds to a magnetic loading and AT corresponds to electrical loading. So AT corresponds to electrical loading and phi m corresponds to magnetic loading. So you have to use this equation. So phi m by 80, the ratio of magnetic to electrical loading is 480 into 10 power minus 8. For this ratio is substitute here. 480 into 10 power minus 8 into 10 power 3. So what you got K. K is equal to 1.03. Once you got K is equal to 1.3 and you can calculate what? You can calculate this ET. ET is something about voltage per turn is equal to K into under root of Q. K is 1.03 and you got KVA is equal to what? 100 KVA. Put in 100 KVA. Then voltage per turn is equal to what? 10.3 voltage. So once you got voltage per turn, always you can calculate the net iron area of the core. ET is equal to 4.44 F into phi m. Phi m can be written as what? Bm into AI. AI you can calculate nothing but net iron area of the core, 0.042 meter square. Now calculate gross core area, gross iron area, AGI, nothing but what? AI divided by KS. AI is 0.042 divided by 0.9 and 0.047 meter square. And gross core area AGI, if you take this core, gross core area AGI is nothing but what? 2A into P. This is a shell type transformer. 2A into P. Okay, 2A into P. And in the problem it is given as what? The ratio of depth. If you see the problem here, condition, the ratio of depth of stacked core to the width of central limb. Depth is nothing but B, width is nothing but A. Okay. So B by A, okay, come here. Okay, B by 2A. B by 2A is equal to 6. The ratio of depth of stacked core to width of central limb is 2.6. Use these two relation and find out 2A and B. So B is equal to what? 2.6 into 2A. So AJ is equal to 2A. Substitute for P. So 2.6 into 2A. Then calculate 2A. 2A what you got? 0.134. Similarly, what you got? A is equal to 0.067 meter. And you calculate B. So like that, what you have calculated, you calculate the dimension of the core. You think what you have 2A into B, you have calculated. Once you calculate the dimension of the core, then you can calculate the dimension of the window and overall H and overall W. For shell type transformer, same formula you can use here. Substitute the things here. Substitute for AI and calculate the area of the window. Area of the window is something about what? HW and WW. And they given the condition HW by WW is equal to 2.5. So use these two equation and find out what? Find out the width of the window and the height of the window. Once you find out the width and the height of the window, you can calculate what? Depth of the yoke, dy is equal to P, height of the yoke, hy is equal to A, and the area of the yoke, dy into hy. Substitute this value, and this is meter square. Okay, just left out here, meter square vector height. Okay, 0.02393 meter square. Overall height of the frame, h is equal to hw plus 2a. Okay, substitute here. Overall length of the frame, w is equal to 2ww plus 4a. Substitute the values and find out the overall length and the height. And similarly, what you do, you calculate what? You calculate the unit details, LV winding, number of turns, current of LV winding, and cross-section area of LV winding. And similar ways, you find out what? The number of turns, current in the HV winding, and cross-section of HV winding or cross-section of your primary winding. Okay, so these are all similar steps based on the conditions. What the condition they'll ask here. So that is why I read out the conditions and you can solve the problem. Very simple problem. These things finding out the winding details and finding out the main dimensions and core dimensions. So altogether, I have done what I have done, around 9 problems. 9 problems based on this 4 problems based only on the dimensions, core dimensions and dimensions of the window. Another 5 problems based on the winding details along with the core dimensions. So this 9 problem is more than enough in examination point of view. Okay. So still, since we have meeting with principal